Today we will be interpreting graphical displays, okay? First, we're going to take a look at some dot plots. The dot plot shows the number of fire trucks at different fire stations. Choose the appropriate measure of center and variation, then use the measures to describe the data set. Okay, so our measures of center that we're looking at are going to be your mean or your median. Your measures of variation are going to be range or interquartile range. Okay, and so first thing we need to do is decide, okay, is there an outlier? Okay, if there is an outlier, then we are going to use the median. Okay, if there is an outlier, we are going to use the interquartile range. Okay, if there is not an outlier, you will use the mean and the range. Okay, so the appropriate measure of center and variation is determined by whether or not there is an outlier. Okay, and when we look at this data, okay, it all falls right here between 1 and 3, and there is no data point that's anywhere far beyond that data. So there is no outlier in this data, which means we are going to use the mean and the range. Okay, your range is the distance between the largest and smallest numbers. Okay, so the distance between 1 and 3 is 2. Okay, so your range is 2. All right, 3 minus 1 is 2. All right, and the mean is, again, we're adding all these numbers up and dividing by how many data points there are. So we have 3, and then we have 1, 2, 3, 4, 5 at 2, so that's 5. And we have 3 at 3, which is 9. Then we're going to add these up. 8 plus 9 is 17. Okay, and then we're going to divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data points. So we're going to do 17 divided by 11, and that is going to give us a mean of 1.54 or 1.55. Okay, and then the range again is 2. All right, so your measure of variation is that range, the measure of center is the mean. Okay, now in number 2 here, this does include an outlier. Okay, this one says the dot plot shows the number of bowling pins knocked down during each turn for 2 friends. Choose the appropriate measure of center and variation, then use the measures to describe the data. Okay, so because there is an outlier here at 0, we are going to use the median and we are going to use the interquartile range. Okay, so your median here, we are going to go through and go from the outside all the way and figure out what our middle number is here, and that is going to be 6. Okay, so my median will be 6, okay? And then my interquartile range. Okay, so we're going to find the median, okay, which we said was 6, okay? And then we are going to look at one side of the data and the other side of the data, and then we're going to find the median of each side of the data, the upper half and then the lower half. So I have 1, 1, 2, 2, 3, 3, 4, 4, 5. Okay, so 8 is the median of the upper half, and the median of my lower half of data is 5. Okay, and then my interquartile range is the distance between those two medians, which is 3. Okay, so your interquartile range is 8 minus 5 is 3. Okay, so again, interquartile range, you find the median first, then you find the median of the upper half of data, median of the lower half of data, okay, and then you find the range between those. Okay, so because there is an outlier, we used the median and the interquartile range for our measure of center and the variation. Okay, so you can try 3 and 4 on your own with those. Next, we're going to take a look at histograms. The histogram shows the number of dollars donated by supporters during a baseball team's fundraiser. Use clusters, gaps, peaks, outliers, and symmetry to describe the shape of the distribution. Okay, so if we take a look at this, when it's talking about clusters, it's do we have a group of data really close to each other? Gaps, are there any spaces that there is no data? Okay. Peaks is where's the highest point? All right. Outlier is we've been talking about those, a set of data that is far away from the rest. Okay. And symmetry is this the same on one side as it is on the other? Okay. If you cut a line down a half, could you mostly fold it right on top of each other? Okay. So if we look at this set of data, if I cut it right down the middle, both sides are not the same. So there is not symmetry. Okay. Um, all right. If we look, there is not a cluster. Okay. The data is relatively spread out. Okay. There is a gap, though, between this 0 to 4. Okay. There is no data here, so that's considered a gap. All right. The peak would be at 10 to 14 hours. Okay. And there is no outlier here. Okay. All the data lies between those, and they're all pretty, got several within each grouping. Okay. So that is how we take a look at each of those things. Okay. So no outlier and no cluster. Okay. Now, number 8, if we look at this one and we draw a line kind of down the middle here, these are relatively symmetrical on both sides. You can see that the ones right next to this peak here at 7 to 9 are the next highest, and then it gets lower from there on both sides. So they are roughly symmetrical. Okay, there is no outlier here, no clusters, and there are no gaps. Okay, no gaps, clusters, or outliers on that set of data. Okay, you can try number 9 on your own, like that one. Okay, now next we're going to take a look at box plots. Okay, box plots, it says the box plot shows the number of prize tickets that Darla won from different games at the arcade. Find the median and the measures of variation. Okay, so the measures of variation again are your range and your interquartile range. Okay, and then we're also finding the median here. Now, one nice thing about box plots is it gives us these points and lines at specific places. So this is my minimum. Okay, this is my maximum. All right, this is my smallest number in the data set. This is my largest number in the data set. Now, this line right here in the middle is the median. Okay, that is the median. So the median is, so if this is 25, it's about at 23. Okay, the median is at 23. Now, this point here is the median of the lower set of data. Okay, so remember earlier we found the median of the lower and the upper set of data in order to find that interquartile range. This right here is that median, okay? So that's between 16 and 20, so we're at 18 is that. And then this median that we looked at earlier is actually at 22, not 23 here. Okay, I was counting those by 5s instead of by 4, so it's directly between 20 and 24, so it's about at 22. And then this median of the upper set of data is between 28 and 32, so it's about at 30. Okay, so that means the Inner quartile range is 30 minus 18, which is 12. And the range is from 8 here at my minimum to 75 here at my maximum. It's just less than that 76 there. So I'm going to say that's at 75, which means our range here is 67. 75 minus 8 is 67. Okay, so your range is 67. All right, so one nice thing about those box plots, again, is that it gives you those data points at specific places. So again, minimum, maximum, the median is in the middle of the box, and then the median of the lower set of data is 18 here on this first line, and the median of the upper set is on that last line. So it makes a box. All right, so they call this box plot or a box and whisker chart. Okay. Okay, and you can try 11 and 12 on your own like that.